Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Muhammad Raffendo, and with name 122490043. So today I wanna completed exercise application counter PLC pada system Pneumatic. So let's look at the background. Modern industry demands high efficiency and accuracy in production process. One technology that greatly support is the PLC, or programmable logic control, an electronic device used to automatically control machines and equipment. PLC are not only capable of turning actuator on or off, but also offer logic function. Actuator on or off, but also offer logic function, timers, and counters, which are extremely useful. Counters are used to count the number of the events. For example, counting product on a production line, or the number of cycles of a pneumatic piston. Without counter, operator will have to count manually, which is clearly impractical. Therefore, the use of counter has become an essential requirement in automation system. Practical objective one is understand the working principle of counter in PLC. Students are expected to understand how CNT, center, and CNR instruction work in counting impulse. Learn how to write counter instruction in ladder diagram. Students will practice writing counter instruction for counting or increment, counting down or decrement, and performing reset operation. And now, how to connect counter to outputs. Student can practice connecting counter to indicator lights, solenoid, valves, or other actuator in pneumatic system. Apply theory to real-world practice. This practical session provides hands-on experience in applying PLC counter theory to pneumatic system commonly used in industry. Why are counters needed? Counters are essential in automation because many industrial processes require precise counting or events or cycles. For instance, in beverage production, a filling machine must stop automatically after filling 50 bottles. Without a counter, the operator will have to count manually, which inefficient and prone to error. Another example is pneumatic system, where our piston may be move back and forth 10 times before stopping. A counter ensures the system automatically tracks the movements. Counters are also used for performing maintenance. For example, after 100 cycles, a machine might trigger an alert for surveillance. Thus, counters are not only used to tally events, but also to improve efficiency, quality control, and safety industrial operation. Definition of counter up or CNT. The counter-op, abbreviated as CNT, is the simplest type of counter instruction in a PLC. It a function to count the number of rising pulse increments from an input every time the input receives on signal, such as from a push-button sensor or a limit switch. The counter current value, or CV, increased by 1. CNT does not decrease values, so it only counts upward. This counter is commonly applied in one-way counting system, such as counting the number of bottles passing the sensor, the number of items per shot, or the number of piston strokes in a pneumatic system. Essentially, CNT is one direction pointer that activates its output when the preset value or PV is reached. How CNT works. The working is principally of CNT's relay forward each time the input is activated. The counter current value or CV increases by 1. The programmer sets a preset value or PV which acts the target count. When CV reaches or exceeds PV, the output bit associated with the counter turns on. At this point, the counter can activate a lamp buzzer or actuator. For example, if PV is set to 10, then after 10 input pulse, the output is triggered automatically even if the input continues to generate more pulse. The counter will keep count beyond PV, but the output remains on since the target condition has already been met. CNT application example. One common CNT application is in pneumatic stroke counting. Suppose a piston is designed to move forward and backward repeatedly. Yes, forward stroke is registered as one count by a sensor. The PLC can keep track the number of strokes, and when the count reaches 10, a lamp indicator turns on to signal completion. Another example is in production lines where CNT counts items in a conveyor. If PV is set to automatically active, CNT greatly improves efficiency by automation process that would otherwise require manual counting. Definition: counter reversible or CNTR. The counter reversible or CNTR is a more defense counter compared to CNT. CNTR can count upward instrument and downward instrument. This is possible because CNTR uses two separate inputs, up and down. When the up input is active, the CV inverse, and when the down input is active, the seekers. This type counter is used application that require bigger counting, such as conveyors that move forward and backward, elevator moving between floor, or pneumatic system where the piston move in both directions. CNTR helps track the relative position or number of operations to diffraction. How CNTR works. CNTR works by monitoring two input simultaneously. When the up input turns, the counter increases the current value by 1. Conversely, when the down input turns on, the CV decreases by 1 like CNT. CNTR also has a preset value or PV. When CV reach or excess PV, the output turn on. However, if CV decreases below PV, the output turn off again. This is dual capability makes CNTR suitable for systems requiring two-way control. For example, as elevator increase CV as it goes up floor and decrease CV as it goes down, allowing the system always track its count floor. CNTR application example. A practical example for CNTR can be seen in a Modul conveyor system. When the conveyor moves forward, the up input activates and the counter increases. When the conveyor moves backward, the down input activates and the counter decreases. Allow the operator to track how many times the conveyor moves forward versus backward. CNTR can also be used in automated storage system where items are counted when entering or up and exiting or down. This way, the system always knows the exact quantity of item in storage. Why reset is needed? A counter cannot run indefinitely without resetting. If a counter continues or moves a value, the result will no longer be meaningful for sub-cycles. For example, if you want to count 10 products per batch, after the first batch is complete, the counter must reset to 0 to start the next batch. Without reset, the second batch will not be counted correctly because the counter will continue from its first value. Resetting ensures that counter start fresh for every new cycle, making the process repeatable and accurate in industrial settings. Explanation of ladder diagram. Explanation of ladder diagram. In the counter up or CNT sections, the circuit begins with a ARM input device such as push button or a sensor connected to address 002 each time. The button is pressed or the sensor is active. The counter receives a pulse and counts upward or increment. The counter instruction use CNT 000 10. Therefore, each input pulse increase the current value or CV by one. And when CV reaches 10, the counter output being turned on. Output is that to active a device such as a lamp or buzzer. Reference at address to activate V116 to allow the counter be used. Timer instruction T000 hashtag 50 is that as reset. This timer runs for 5 seconds or 50 kali 1000 ms, and once the time expires, the counter automatically resets, bringing CV back to 0 so the counting process can start again. Is the counter reversible? Enter sections the ladder diagram make use to input, one for up and another for down. The up input ag button address 113 increase the counter, while down input or another sensor or the reset time T111 and T0001 decrease it. The instruction used to here is enter 001 hashtag 10, meaning the counter at address 0001 as a preset value of 10. When the up input is activated, the CV increase. When the down input is activated, the decrease. The output turn on if the CV equal or greater than 10, but turn off if the CV drops below 10. Similar for the CNT example, this section also includes a timer at address T0001 hashtag 50, which automatically resets the counter after a certain period. The output controlled by the reversible counter zone address V007, which lights up when the preset count is reached. Why reset is needed? Overall, these ladder diagrams demonstrate how counter can be applied to control pneumatic system. The counter up CNT, added counter up or CNT, is used for one-way counting, such as counting the number of piston strokes, while the counter reversible is used for bidirectionally counting, such as forward and backward motion depending on input conditions, with the addition timer for reset. But counters can be used continuously in different cycles. This illustrates the practical application of counter in PLCs for controlling automatic industrial process, whether for counting cycles, tracking product, or monitoring actuator movement in pneumatic system. So I'm sorry before I have wrong word. So wassalamualaikum warahmatullahi wabarakatuh.